seen binomial distribution. I'm repeating it with additional work. If there are any doubt, difficulties, you can ask. There is no revision for binomial distribution. Let me share with my module 4 question paper. Following are the assumptions of binomial distribution. Number of observations n is fixed, that is sample size. Each observation is independent. Each observation either represents success or failure. Probability of success P, probability of failure 1 minus P. Number of successes in the experiment is variable X. And probability for that is binomial distribution. In question number 1, 6 independent trials, probability of success 0.3. You are supposed to find the probability for 0, 1 or 2 in the sample. X is number of successes. So I said at that time, let us assume 6 customers. Success means they prefer coffee. P, probability of success. So we want probability X is equal to 0, X is equal to 1, X is equal to 2. And in the next example, probability of producing a perfect drill to get oil is 0.95. If 5 drills are chosen at random, what is the probability that 3 are perfect, 4 are perfect, 3 or more perfect? And in the next example, random sample of 4 students are selected from the institute. They have a probability 0.80 to get an average in the course. Evaluate all of them. Improve their average. I converted that into 10 student example. Find between 3 to 7 inclusive, greater than 8, less than 9. So these are all questions first I will be going to do again with explanation in R. In the first question, x is 0, 1, 2, 3, 4, 5, 6. Six customers. Find the probability distribution of x. So D binom is the function. D binom helps you to evaluate probability for each value of x. This is what our answer. I can plot a graph also. I can plot x values also vertically. So the vertical line intersect at probabilities. And we want the probability for 0, 1, 2. So we have D binom for each. We got it. This is what our question number 1. I can compute the probability by D binom. I can plot it on the graph and so on. Now let us see question number 2. Five drills are there with probability 0.95. Instead of x, I denote another variable x1, not to get confused. And here I can get the probabilities for each. I can plot also on the graph. It is a repetition of question number 1. Situation different. Situation different. So D binom helps you to individual probabilities. At the same time, P binom gives you cumulative probability. We can plot cumulative probabilities also. We can plot cumulative probabilities also. We want exactly 3, exactly 4, and 3 or more. So these 3 probabilities are also we can find by D binom as well as P binom. You can find Another way also, for 3 or more. So 3 or more perfect drill, meaning 3, 4, 5. So I denote the range 3 to 5. Evaluate the probability by D binom. But sum. Got it. You can plot that also on the same graph. You can plot it on the same graph. So this is first 2 questions. This is set of algorithms to answer question number 1 and question number 2. Let us see question number 3, first part. 4 students are selected from the institute. Four students are selected from the institute. The chance of improvement is 0.8. Evaluate the probability all of them improved. Evaluate the probability that all of them are improved. I modified it for a sample of 10 students. First question is, what is the probability that 3 to 7 inclusive improve? So I define the range 3, 4, 5, 6, 7. Add the probabilities. This is what the probabilities. And the first part 3 to 7 inclusive is also shown on the graph. And in the second case, greater than 8. Greater than 8. That means 9 and 10. See? See the probability in 9 and 10? And in the third case, less than 9. That means 0 to 8. So the probabilities are respectively this much. This is what initial work in binomial distribution. Any question?
So,
Yes.
could you scroll up the editor a bit?
Yeah.
Okay, got it. Just wanted to see R2.
Yeah. Any question?
Sir,
Yes.
R2 and R3, should it be written C9, 10 or should it be 9 colon 10?
Colon 10. No, colon, not comma, colon. Range है वो. 9 to 10. That is the meaning. 3 to 7. 0 to 8. Any other question?
Sir, what if I don't define the range? If I'm not writing R1, R2, R3, I'm still getting the answers.
Yes. Yes.
So
yes.
what
But
difference?
for plotting, I want.
Okay, sir.
For plotting, I want the range. Any other question?
So in R1,
Yeah, ask.
so in R1, rather than writing 3, 4, 5, 6, 7, can we write 3 colon 7?
Yes,
Okay, sir.
you can. I have written in R3. देखो.
Yes, sir.
Yes. Any other question? All right. So today we are going to do some additional work. Today we are going to do some additional work. That additional work will be in the poultry farm example. The poultry farm manager states that an egg, it is singular, an egg damaged at the destination after transportation is 0.32. It is 0.32. One tray can occupy 6 eggs. I'm going to do something new on this. $500 trays are transported to the distributor by road. Find how many trays are having 0, 1, 2, 3, 4, 5 or 6 eggs damaged per tray. This a real situation we write in statistical way. A tray has 6 eggs, so n equal to 6. Like 6 customers, 6 drills, 6 students, and so on. Probability that an egg damage 0.32. ये दोनों सिंगुलर है. 1 tray, 1 egg. So per tray, there can be 0, 1, 2, 3, 4, 5 or 6 eggs damaged. How many? We don't know. So we say X. So a single tray is a binomial model with parameter n is equal to 6, p equal to 0.32. So I converted the real problem into statistical model. I converted the real problem into statistical model. Now, this is repeated for 500 trays. That is capital N. So, we have to find how many among 500 has X damaged eggs per tray. Classify the shipment according to X value. Frequency distribution of 500 trays according to X values. So that is what our research objective. Classify them. Any question? Yes, any question? No. Okay. So let me go for my R package and find out the output. Let us see what we can do later. So I denote W. W means per tray how many eggs are damaged. And the probability will be 0.32. So for single tray, this is the probability distribution. For a single tray, this is the probability distribution. Multiply that by 500, I will get the frequency. Plot them, I will get the graphical representation of the frequencies. graphical representation of the frequencies. It is graphical representation of the frequencies. Suppose if I change it, instead of 0.32, I make smaller probability, say 0.15, so which graph is better for the business?
So with probability 0.15.
Correct. Smaller the probability for damaged egg, higher will be the profit made by the sales manager, less will be the complaint from the distributor. Now, today, some additional work that we are going to do. The work that we are going to do today is finding binomial cutoff points. Binomial cutoff point. What does it mean? Same example. W binomial distribution with probability 0.89, 0.32 itself I will take. The very first question is, find K such that probability W greater than K is 0.35. The meaning, find value of K above which binomial probability in the sample is 0.35. This is the meaning. Reverse way. So far you were finding binomial probability, but now binomial probability will be given, find out the corresponding value of the variable. Clear?
So can you please repeat?
Yes. See the way that I have written on the editor.
So what is 0.65 there?
Yeah, wait. Find out K such that above which binomial probability is 0.35 in the sample. Now it's clear.
Yes, sir.
And for finding the cutoff point, Q binom, not D, not P, Q stand for quantity. See the syntax? K is Q binom and cumulative probability from minimum to the cutoff point. So above K 0.35, So less than or equal to k, how much?
0.65.
Yes, because total probability will be always 1.
1. Yes, sir.
So the syntax will be Q binom lesser cumulative probability, comma, n, comma, binomial p, small p. And you will get it on the graph as well as computation. Two. Two is the value for W above which the probability will be 0.35.
They can't get the 0.65. That is the lesser cumulative value. How we derive, sir?
Yes. That is the syntax. Suppose if I change 0.59, let us see what we get. I can plot this also on the graph. Oh, but graph I have not plotted. So plot binomial probability curly W This is my probability. The cutoff point I will show there. Below it is 0.65 and above 0.35. Cutoff point divide the total probability to the left and to the right. See one more example. Find Z such that probability W less than or equal to Z is 0.59. So make it number little higher if you want 0.79. So again I got 2. Why it is not changed? Anybody? Oh, sorry, not, yeah. Sorry, 1 minute.
3-2.
Yeah. 1 minute. Three. So this way, cutoff point is dividing the total probabilities into 2 parts. Lower part, upper part. You have to know this. Because when we are going to do test of hypothesis, you have to know how to do such work on the graph. So 3 functions you have learned: D binom, P binom, and Q binom.
Excuse me, sir.
Yes.
Sir, here in Q binom, when we are doing for 0.79, shouldn't it be 0.21, 6, 0.32?
Wrong, because 0.79 is the lower cumulative probability in the question. Dekh lo. W less than or equal to Z. Earlier it was greater than.
Okay, sir.
Syntax will be always lesser cumulative probability. So here 0.79 is the given less than cumulative probability. So no need of converting that. Okay. Now, 3 functions you have learned therefore. D binom, P binom, Q binom. Here 500 trays are there. So W has how many values in the shipment? Anybody?
$500.
500. 500 values. The values are anywhere from 0 to 6, isn't it?
Yes, sir.
Okay. So, suppose if the distributor check the 500 trays, he will get 500 values. That is what we call the larger sample data. So R binom will tell you a random sample generated by you to see the nature of the data. R binom. R binom tells you random sample from binomial distribution. $500 will be by larger data. 6 and 0.32 are by given parameter. So I have here now by syntax R binom 500, 6, 0.32 and see the output. If on your screen data need not be same as mine because random sample. But everybody will get a value 500. Each one will be anywhere from 0 to 6. Any question?
Sir, 500 value between 0 to 6 and 0.32 is?
Probability.
Sir, in this sample, it's probability of?
No, P is the probability of success. That is parameter of the distribution. Tray ka.
Okay, sir.
You are generating 500 values from binomial distribution. And for this, you can find the mean, variance, and standard deviations that already everybody knows. That everyone knows. So in my case, per tray, average damage egg will be 1.9 with a standard deviation 1.14. Instead of 0.32 for p-value, if I take smaller value, will my average increase or decrease?
Could you please repeat your question, sir?
Yes. My p-value is 0.32 in this example. And the average damaged egg per tray 1.91. Instead of 0.32, if I reduce to 0.22, will my average increase or decrease?
Decrease, sir.
Verify. Let us see. Data and my computation. Decrease. So smaller the average per tray, better will be the business.
So will we get the same mean, variance, and standard deviation values as you are?
No. Because yours is a random sample, but average will be smaller now.
Okay, sir.
You will not get my answer. But your average will be smaller than earlier average. And I can plot the data also by histogram. Histogram, HIST, with the data. See. I can give the color also. So where will be the more trays? Is it to higher values or smaller values of W?
Smaller.
Correct. Why? Because my probability of damaged egg will be smaller. And huge data will be to the smaller value, so average also will be small. Can anyone tell me? Instead of histogram, which other way I can group the data? Table form.
Sir, stem and
Yes,
leaf
please.
stem and leaf diagram.
Table form. I can get the table also. See. So by this, all the function By this, all the functions related to binomial distribution I have explained you. D binom, P binom, Q binom, R binom. Syntax you have to be very particular in writing. You are able to evaluate the probabilities. You are able to evaluate cumulative probability. You can find the cutoff points. You can generate the data. From the data, I can plot a graph. I can compute mean and standard deviation, etc., etc.
Sir, I have a question.
Yes.
In this random, sample that we generated, so we are not getting any values for 5 and on an average, how many trees would have 5 and 6?
Why? Because your probability of success will be very small.
So, but because we are not getting any value, does it mean that there are no chances for a tree to have 5 or 6 eggs?
Yes, we don't have it then.
Okay, sir.
We don't have it.
Sir, for me, I'm not getting a value for 5, but I'm getting a value for 6. 1.
Possible. Possible.
So it's possible to have all perfect eggs, but not one.
Yeah. But the frequency for higher value will be small.
Yes.
But what I want to say is, smaller the average, higher the probability for not damaged eggs. So, binomial probability distribution is a discrete probability distribution. Because the experiment will result on countably finite values. Like 0, 2, 1, 2, 3, 4, 5, 6 up to n. It cannot take decimal values. It cannot take decimal values. It always go for countable data experiment.
Sir, sorry to interrupt, but what is Q binom that you are actually taught? Sir?
Q binom?
Yes, sir.
Quantity ray. Given the binomial probability, find the corresponding cutoff point.
Sir, when we say we are trying to find cutoff point, does it mean that for this probability, how many eggs would be broken? Minimum?
Yes.
Okay.
Yes.
Like minimum, we are expecting 2 eggs would be broken for 35% probability.
Right.
Okay.
And if it is the other way, maximum.
Okay, sir, got it.
Either W less than K or W greater than K. Because after that, the full range is divided into 2, na? When you are finding the cutoff point, you are having the range. Dekh lo. See that. Find K such that W greater than K 0.35. Next question, W less than Z. No matter which one, finally you are dividing the total into 2 parts. So Q binom generally talk about the bifurcation of the probability distribution above, below certain number. Therefore, every part that related to binomial distribution is explained here. This is a discrete probability distribution. Countable values are the range for the entire variable. Is it in real life always countable data? Not necessary. Height of an individual is at random, measured in centimeter. Weight of the individual is measured in kilograms. Temperature is measured in degrees Celsius. Rainfall is measured in mm. So wherever measurable characteristics are observed in the sample, binomial distribution will never help you to answer probabilities. Measurable characteristics are called continuous characteristics. Continuous characteristics. One such probability distribution also we have to introduce today. That is normal probability distribution. That is normal probability distribution. A normal probability distribution is a non-discrete model. It is used for continuous type characteristic. The probability graph of normal distribution is always symmetric. The probability distribution has only two parameters, arithmetic mean mu and standard deviation sigma. Probability distribution is symmetric at mu. That means probability x less than mu is same as probability x greater than mu, which is 0.5. Which is 0.5. So here you don't have discrete value. It can be any value on the real line. Like binomial distribution, here also we have to go to probabilities. We have to go probabilities, D binom, P binom, Q binom. Same way, D norm, P norm, and Q norm. Every work we can repeat now. Every probability technique we can repeat now. This is the mean. Only the distribution differ. So, parameter mu and sigma, if you know, you can evaluate several probabilities. You can evaluate several probabilities. Let me show you once again a graph. Suppose the parameter mu and sigma equal to 200 and standard deviation is equal to equal to 20. Suppose in a data not given to you, but I can plot the data now. In binomial, what happened? In binomial, what happened was I generated the data. So here also I can generate the data. But whichever may be the data among the student, the graph remains symmetric. That is what I want to show. Plot normal distribution graph. Plot normal distribution graph. That is what I am going to show. So I'm continuing the same file, normal distribution now. I'm going to repeat now complete work of binomial distribution in normal probability distribution. So I want to show you the meaning of normal distribution when mu equal to 200 and standard deviation 20. So I have now normal distribution sample. Data. R nor bracket say 500 or say 300, comma mu value 200, comma standard deviation 20. See the data now. See the data. I can plot the histogram. I can plot the histogram. See? Vertical equal to mu. What is happening on the graph now? What is happening on the graph?
Data is divided into two halves.
Correct. What is happening to the left side and the right side of the cutoff point? What is happening to the left side and right side of the cutoff point?
So graph is symmetric.
Symmetric. This is what I have told you. Normal distribution will be always symmetric. Even data different, but your graph, my graph, and others' graph, all will be symmetric. Isn't it? So 50% of the data will be above the mean. Another 50% of the data will be below the mean. Can anyone tell me? Instead of standard deviation 20, I take the standard deviation 10. What is happened to my graph?
So the graph will narrow down.
Graph will be?
The narrower.
Narrow, matlab where it will be? By which side it will narrow?
From the peak.
So both sides will shrink towards the mean.
Yes.
So it will be still symmetrical.
Yes, very symmetric, because the points will be much nearer to mu. Dekh lo. Suppose if I reduce further, tell me, what is the meaning now? As the standard deviation smaller, come on.
So data is more
Closer to
the mean value.
mean value.
More closer to the mean value.
If smaller the standard deviation, closer will be the mean value. Say one more example. Division A has mean 69 marks with standard deviation 11. In division B, the mean is 69. But standard deviation is 7. Which class has better performance?
So division B.
B.
B. Though the average remains same for both the divisions, standard deviation is smaller to B division. Performance is better in B division. Smaller the chance of backlog in B division. So the arithmetic mean need not be same. Anything can happen, therefore, when you are talking about normal probability distribution in analysis. Okay. This is what the characteristic. Suppose instead of 200, I can generate 1,000 observations. I can plot them. Every time when you talk about the value, you are going to get graph. Clear now symmetricity? In testing of hypothesis, we are going to use it now. In the next module, next class, it is higher level. Mean of normal distribution, standard deviation of normal distribution, both are very important parameters. They helps us to do the analysis. So to explain today for the remaining part of the session, let us do 1 or 2 examples. Attentive. I'm going to do the example now. Let me share with you the question paper. First one. A market research company employs a large number of typists to enter the data into a computer. A large number of typists. The time it takes for the new typists to learn the computer system is known to have a mean time 90 minutes with a standard deviation of 18 minutes. Data not given to you. Instead of the data, you have given the parameter mu and sigma. What is the proportion of new typists who take more than 2 hours to learn computer system? Can you tell me what is the answer without computation?
Sir, 0.
0. Perfect. Why?
Because sir, 90 plus 18 is 108, wherein like, in 2 hours it's 120 minutes. So the upper bound is 108 minutes. So like no typist would take more than, like that's my interpretation, could be wrong.
Very good. Your interpretation is perfect.
Okay, sir.
Average is small, standard deviation is small, no data with 120 minutes. So the answer for the first question is 0, not possible. Let us find out some other probability greater than 78 minutes between 67 and 98 minutes. That is what I'm going to work out. So the first probability not possible. First probability not possible. So I'm going to start my work with example 1. Given the mean 90 minutes, standard deviation 18 minutes, find the probability x greater than 78, probability between 67 and 98. So the first work is on this. Yes. P binom. Because these all are cumulative probabilities. These all are cumulative probabilities. So P binom in binomial probability, P norm is normal probability. So the first answer, A stands for A part, is 1 minus P norm. 78, 90, and 80. Next part, PB. P norm, upper bound 98, 90, 18, minus P norm 67, 90, 80 is the syntax. That is the syntax. So PA, PB.
Sir, I have a question.
Yes.
In this question, we are trying to find proportion of typists who take more than a particular amount of time or like
Yes.
fall in a particular range,
Yes.
right?
Yes.
So when we are defining our n in this particular...
No n here. Not at all an n in normal.
Sir, what is the first argument in this syntax? That's
78. Cutoff point, 78.
Okay, that is the cutoff point.
Yeah. And mu is 90 and standard deviation 80.
So, sir, this cutoff point would give us the proportion of people, or would it give the
78 is the typing speed.
Okay, sir.
Answer is the proportion of typist taking more than 78 minutes.
So answer would be like the number that, so it is the probability, right? That we would
Probability means proportion, percentage.
Okay, so okay, got it, sir.
So 74% of the typist take more than 78 minutes. Approximately 57% of the typist take the time between 67 to 98 minutes. Any question?
So why are we using here P norm? Can you please explain?
Normal distribution. We are studying the normal probability distribution. So P norm is the function to evaluate probabilities. Yes, any other question?
Sir, can we find n also?
N we cannot ray, N is not given.
Yes, sir, it's not given, but in this in a question, if we are given with the mean and standard deviation,
yes,
so basically, if we calculate z score, x minus mu by sigma upon root 10, and if we are given that x value also from which we are trying to compare,
x minus mu by sigma by root 10 etc. comes out to be later work in sample. Here we are not doing sample, we are evaluating probability of the variable.
So here n does not matter.
Ah.
Okay, sir.
I will repeat this example. Just imagine. Suppose 350 typists came for the experiment. So the data is a random sample 350, 90, 18. Suppose. So histogram I have. I have here histogram. Histogram data color yellow.
There it is throwing an error.
Yeah. 1 minute. 350, 90. Okay, understood. Data not typed. Now I will get it. Are histogram data color is yellow.
You have typed there RS. You need to type R norm.
Yes, RS.
Oh, R norm. Sorry. R norm. Sorry. So now I will get the data as well as the histogram. So where is this probabilities now? 78. 78. So AB line vertical equal to 78, comma, color equal to blue. So below blue, how many typists are there? Anyone? Below blue, how many typists? Below blue line, how many typists we have?
78.
70? 77. 74% of the typists are below blue line. Similarly, '67 and 98 is the interval. I want to show the interval on the graph So between the red lines, how many typists?
57.09.
Correct. Correct. So like binomial distribution, using normal distribution, you can evaluate the probability and you can show them on the graph. Yes. In testing of hypothesis, I'm going to do that. Any question? It is not over. One more part is there that I have to do.
Sir, in the first AB line, we equal to have written 78. Shouldn't that be 90? The mean.
Mean nahi hai. My first question is above 78 minutes. So the cutoff point I am showing is 78. I am not plotting the mean. Mean and standard deviation always we have.
Okay.
Is it clear?
Sir,
Yes.
so the first example which you took, that probability the time is greater than 120 minutes, that cannot be zero now.
It is 0.
But like,
because the mean is 90.
Yeah, so like data within the
This is
standard
given to
deviation.
you. If you compute the probability, you will get greater than 120 is very, very, very small.
Yeah, it will be very small, but it won't be zero now.
It is approximately 0. This is a data for 350 customers only.
Yeah.
Okay.
Yes, sir.
If you want, you compute the probability and check. You will get approximately 0.
Yeah, it's
Any
coming
other?
out 0.04 something.
Now, the next part is find out K such that 20% of the typist complete the typing with maximum speed K minutes. This is the meaning. Is that clear? Find k such that probability x less than k point 20 reverse the way. 20% of the typists complete the work below k minutes. Find k. So k is q norm. Point 20, comma 90, comma 80 is the syntax. So what is that 74.8, that is 75 minutes tells? What is that 75 minutes?
Means that 20% will complete their work within 75 minutes.
Correct. 20% of those typists who came for the test complete typing in 75 minutes. I can plot it also on the graph. Say one more. Find C such that probability x greater than C is equal to 0.15. So here C, Q norm. Yes, what shall be given inside?
0.85 there.
Correct. 0.85, comma 90, comma 18. So I will get the cutoff point. Approximately 109 typists, sorry, approximately 15% of the typists take the time above 109 minutes. I repeat, the main objective here, percentage of the data below, above, interval using normal distribution. The only parameters given to you is mu and sigma, mean value and standard deviation. And your job is use p-norm to evaluate probability. Use q-norm to generate the data for graph. That is the work I have shown. Last part of today. Suppose find central 50% interval. For normal distribution. That means A comma B, A comma B, such that probability X less than A equal to 0.25, probability X greater than B equal to 0.25.
So greater than the 0.75.
Central interval. So between A and B, how much percentage? 50%. Central 50% interval means beyond the interval another 50%. But this another 50% is to the lower value as well as upper value equal. So A is Q naught 0.25, 90, 18. B Q naught. Come on.
0.75.
0.75, 90, 18. See the output now. If I plot this on the graph, you will find out equally likely. Say AB line, bracket, vertical equal to A, AB line, bracket, vertical equal to B. Let us plot it. See. So above 25%, below 25%, and in between 50%. Can anyone tell me the name of A and B? Can anyone know another name of A and as well as B?
Interquartile range.
Correct.
First
Quartiles. A and B are second and the third quartile. So this central 50% means the entire data divided into 4 equal parts. Center will be the mean. A to be 25%, mean to be 25%, beyond the interval 25-25. So the central 50% of the data in the normal distribution we speak as quartile interval. Quartile means dividing the whole set of observation into 4 equal parts. Yes, please. Yes.
No, sir, no question. Just
okay. A is called lower quartile, B is called upper quartile. and the center is called second quartile. That is arithmetic mean. So this is the introduction of normal distributions. It's not over. This is a small introduction of normal distribution. And you found out now binomial distribution as well as normal distributions are very powerful probability model. Without knowing them, you cannot go for answering the questions. Without knowing, you cannot go for answering the questions. Where it is normal, their binomial is useless. Where binomial, normal is also not possible. So they are separate probability distributions. They are well-defined probability distributions for evaluating several things in the data. They are separate probability distribution for generating the data. Varun Bajaj. Varun. Varun Bajaj.